Up and running again. This should be a short and sweet video. Only going to do two problems. But the second one we do is going to have significant ramifications for the rest of the term. All right, so we started off defining the operations, exponential operations. We've been working with that. And then we looked at the inverse of exponent to quantity. Now we're going quantity to exponent. We've been working with that. We've introduced how to graph exponential functions. Had an assignment. We've had rapid fire five in a row. We've been doing them in class, trying to get to doing them in class. Some folks maybe have not given that their attention that probably it deserves. But one more time, we're looking at it here. And we're going to do a specific exponential function that is going to launch us into about 10 to 15% of the questions you're going to see during the remainder of the term that we hope that you can work with and gain some literacy with. All right, and so these exponential functions, we've been talking about where the base of an exponential function comes from, but we're going to turn all of these exponential functions into a similar base, a base that the world works with. All right, so 2 to the x, 3 to the x, 1/2 to the x, 1/3 to the x. We're going to learn to write that in a same base notation. And we're going to get started with that discussion in this video. And then we're going to learn how to sketch in that base, both exponentially and logarithmically. Okay, they're inverses. All right, we want to be able to get good at sketching in that notation system. And we'll be solving equations in that notation system, both logarithmic equations and exponential equations. And you've been introduced to the inverse of an exponential equation. It doesn't mean you understand it yet, but the conversation has started. So might as well plant the seed here. What's the inverse of 2 to the x? Okay, you hear it again. Log base 2 of x. And if you want to understand that, you should work with some numbers. Let's work from 2 to the 3. 3 gets you 8. Okay, over here, log base 2 of 8. 8 gets you 3. Right, so you've seen it one more time. All right, so let's get to the heart of what we're doing in this video, which is being able to take some data, 2 points and an asymptote, and quickly write that equation. And I'm just going to do it. You've got practice, rapid fire 5, the previous assignment. I'll just do this one. And if you're having trouble understanding it, you've got to look at the answer. You got to look at the numbers. Oh, I didn't put a number up here. How about we go with 16? Okay. So you got to look at the answer. You got to look at the numbers. And the first thing you got to do in the learning experience is sort out what goes where. And then we keep talking about it. All right. So I got 7 plus 4. Not 4 the next time. 7 to 11 is the 4. 7 to 16 is 9. And 1999, x minus 1999, that gives me b to the 0. And that is one of the things we've been talking about. And an elapsed time of 26 years. All right, so you need to look at that and sort it out. Now we're going to do the most important exponential function of the semester. Remember, you can replay all these things. Asymptote, y equals 0. Exponential growth. 0 gets me 1. 1 gets me roughly 2.71. Notice I said roughly. Pause the video, write the equation. I'll just continue on. So 0 plus 1, not 1 the next time, 2.71. X minus 0 over 1. That follows the mechanics of the previous problem. I think there's an awful lot of writing there that I didn't need to do. In fact, I think I can erase the 0, the 1, division by 1, division by 1, subtraction of 0, and it sure looks like I'm looking at 2.71 raised to the x. And what I'm saying is that is a very important function. So important, we give it a different name for the person who kind of came up with this. Right? Just like pi has a decimal name. Pi, it's really approximately equal to 3.14. This number is going to be more important to us right now. E is approximately 2.71. And it's got some magical qualities to it that we'll talk about in class. And we will develop that concept. But for right now, you want to know that an approximation for this number is 2.71, the same way 3.14 is an approximation of pi, which is the circumference divided by the denominator. That's where that number comes from. Circumference of any size circle divided by its denominator comes to you in a ratio of 3.14 to 1. This function, extremely important. All right, so that's it. That's it for the video today. We're going to talk about how important this is and why, future videos and in class. Okay, so that's all you have to do. But keep in mind that knowing that is going to morph into a whole bunch of topics. So you want to keep pace, spend some time thinking about what was just drawn there a second. All right, and got the weekend to sort this out and think about it. So my I guess advice would be, play those two drawings, to look at them, spend 10 minutes tonight, 10 minutes tomorrow, 10 minutes Sunday night. It's going to mean a whole lot more to you if you do that. Good luck with it.